we're continuing chapter 4.4. Tonight's homework is 38 through 96 even. 38 through 96 even. Now, I have been talking about reference angles without you realizing what a reference angle was, but I've been talking about it, okay? Do you remember whenever we were learning the unit circle, and I said, hey, if you know quadrant 1, then you know the entire unit circle. Because every single angle that has a denominator of 6 corresponds to the square root of 3 over 2, 1/2. Remember that? Every angle that has a denominator of 4 corresponds to the point square root of 2 over 2, square root of 2 over 2. And every angle that has a denominator of 3 corresponds to 1/2 square root of 3 over 2. Do you remember me talking about that? And I said the only thing that you had to do were to memorize quadrant 1. And once you memorize quadrant 1, you have the entire unit circle. You just had to add the negatives for the quadrant that you are in. Well, what I didn't tell you is what you are learning was what we call a reference angle. A reference angle is an angle that is formed using the x-axis, the horizontal axis, and the angle. And you're trying to get a measurement that is less than 90 degrees. You're trying to get a measurement that is less than 90 degrees. Now, it kind of jacks with your head a little bit whenever the angle is negative, because you have to either add or subtract your numbers whenever that happens. So basically what this is this is the formula with the premise that we're talking about a positive angle. So if you're in quad 1, the angle theta has a reference angle of theta prime. They're the same thing. If you're in quadrant 2 has an angle of theta, and theta prime is going to be the calculation of the 180 degrees minus that angle, which will give you an angle less than 90. Make sense? If you're in quadrant 3, you have an angle larger than 180, but I need to be able to get the angle that forms between the horizontal axis and the angle. So we're going to take the angle that they gave you and subtract off 180, and that's going to give you a number less than 90. And then if I'm in quadrant 4, I still have to use the horizontal axis. So instead of using 180 this time, we're going to use 360. And we're going to subtract the angle theta that they gave us to obtain the reference angle theta prime. Do we all understand what I just said? Now, it's kind of wonky until you do it. So if it is given to you in radian mode, it is super easy. If it's given to you in degree mode, you got to think a little bit. Okay? You ready? So an example. I give you 300 degrees. What quadrant is 300 degrees in? Well, here's 0, 90, 180, 270, and 360. 360. How about I write that correctly? Okay, so 300 degrees puts me right here. So your reference angle is going to be 360 minus 300, which gives you 60 degrees as your theta prime. So how do I graph them? This going around is theta. Does everybody see that? Theta prime is the little slice right here that is only 60 degrees. Okay? How about when theta is 2.3? Same exact thing. So I have 0, 1.57, 3.14, 4.71, and 6.28. Where is the angle 2.3 at? It is going to be in quadrant 2, yes? So if I'm in quadrant 2, this is going to be theta, which is going to be 2.3. I need to find the little slice that is between here, which is theta prime. So how do I find that? By taking 3.14 and subtracting 2.3. So when you take 3.14 minus 2.3, you're going to get 0.38, 0.84. I cannot type or read today. And that number is less than 90 degrees, which in decimal form is 1.57. Do we all understand that? Yes or no? We good on that? Uh-huh. Now, it's super easy when you're in radian mode. And the reason why it's super easy when you're in radian mode is if I give you, can I have that too? I know, right? Okay, 39. How do you do problems 37 through 44? This is how you're going to do problems 37 through 44. 37 through 40 are in degree mode. So if I'm doing 39, this is a negative angle. A negative angle means that I'm going to be opening up in this direction. This is negative 135 degrees, which is going to be theta. Do we all understand that? I need theta prime, which is my reference angle, and that is this little slice of the pie right here. How can I use the number 180 or negative 180 in conjunction with negative 135?
Well, you can just subtract.
Either way, it doesn't matter. I'm going to take 180 minus the angle that I have there, and that's going to give me the slice of pie that's left over. And what is that going to be? Sorry? We're going to say it's positive 45 because a reference angle is always going to be a positive number. So this refers to a 45-degree angle. Do we all understand that? The reference angle is 45 degrees. That is how you're going to do 39. Okay? Now, if you're looking at 41, number 41, it gives you theta is 5 pi over 3. Well, if I graph 5 pi over 3, this is going to be 3 pi over 3, so this is 6 pi over 3, so where's 5 pi over 3 at? What quadrant?
4.
It's in quadrant 4. And that's going to be right here. The arrow, there's theta. I don't even have to do any math. The reason why I don't have to do math is because my denominator is 3, so therefore my reference angle, which is theta prime, is going to be pi over 3. And that is going to be right here. Why? Because the denominator is a 3. If the denominator was a 4, what would my reference angle be? Pi over 4. If my denominator was a 6, what would my reference angle be? Pi over 6. Do we all understand that when it's in radian mode? So that is how you're going to do 37 through 44. Okay? The next set of instructions is exactly the same, except for these are not measurable angles on the unit circle. They're angles that represent a number that you did not memorize. Okay? So if I want to do 48, where it says theta is equal to negative 95 degrees, how do I do that? Well, it's exactly the same concept. Here's going to be 0. Here's negative 180. This is negative 90. Where's negative 95 at? It's in quadrant 3, right? So how do I get the reference angle? Well, it's negative. I need it to be positive. So I'm going to just simply add 180 degrees to that. So if I add 180 degrees to that, what does that give me? 85 degrees is my theta prime. How do I sketch that? That is my theta prime. It's the little slice between the horizontal axis and the angle. Yes? That is how you're going to do problems 45 through 52. Any questions over that? Huh?
Well, we have to sketch.
Yes, it does say to find the reference angle and sketch it in standard position. Okay? So you do want to sketch it every time. So that's how you're going to do 45 through 52. We good? Okay, 55. 55 through 66. Actually, 53 through 66. It says, evaluate the sine, cosine, and tangent of the angle without using a calculator. So you're going off of your lovely reference angles, which is all quadrant 1, right? So if I'm at negative 750, that's a super big angle. It's a corkscrew angle. Would you agree? So I need to add 360 until I find myself where? Below 360. So if I add 360, come on, help me out, guys. Let's make sure we're doing it right, because whenever you guys do this, you screw it up every time. Yep, no, negative 390. Add 360, and then you know it's going to be negative 30. Add 360, and that's going to be positive 330. Do we all understand that? You keep adding the 360 until you get a positive angle. Do we all understand that? Okay, well now, where am I at? Where's 330 degrees? Well, here's 360, so 330 is going to be right there. So what is my reference angle? How many units difference is there? The difference is going to be 360 minus 330, which is going to be 30 degrees. So this is 30 degrees, and that's your reference angle. What ordered pair deals with 30 degrees? However, I'm in quadrant 4, so in quadrant 4, my sine value is negative. So if I want my sine, cosine, and tangent, the sine of negative 750, the cosine of negative 750, and the tangent of negative 750. What is the sine? Negative 1/2. What is the cosine? And what is the tangent now? 1 over the square root of 3, which is negative square root of 3 over 3. That looks like a 2. Okay? That is how you're going to do problems 53 through 66. Shall we do another one? Okay, so this is 66, and this is straight out of your homework. Now, you can do this the same way we just did the degree problem, but I think it's a lot easier than the degree problem. And the reason why it's a lot easier than the degree problem is because my reference angle is a dead giveaway, because all I have to do is look at the denominator. Yes? So I know this refers to pi over 3, which refers to the ordered pair 1/2 square root of 3 over 2. Would you agree? Yes or no? However, I need to know what quadrant negative 20 pi over 3 is in. So you literally can just kind of graph this. You can say this is going to be 3 pi over 3, so this is going to be 6 pi over 3. So what's that going to be if I multiply that by 2? Which is 12 pi over 3. And yep, that's not over that. So what is that going to be? Do it again. 18 pi over 3, which is the same thing as 24 pi over 3, right? Did 24 pi over 3 get me over that? Yes. So if I add 24 pi over 3, what does that give me? Negative 20 plus 24. 4 pi over 3. So what this means is 4 pi over 3 is going to be where? Right here. So what quadrant am I in?
3.
I'm in quadrant 3, which means this ordered pair has to have a negative here and a negative there. Do we see that? Which means I need to find the sine of negative 20 pi over 3, the cosine of negative 20 pi over 3, and the tangent of negative 20 pi over 3. So what is the sine? Yep, negative square root of 3 over 2. What is the cosine? Negative 1/2. And what is the tangent? Positive square root of 3. Do we understand how to do problems 53 through 66? Does that make sense? You good? Okay, the next section, which is 67 through 72, says to find the indicated trigonometric value in the specified quadrant. Okay, so what they give you is they give you a trig function. They give you a trig function, then they give you a quadrant. Now, I'm going to do this example because it leads straight up into this, and it's really important that your brain understands this. Let's say that you were given that the tangent of theta is negative 5 over 4. The negative is in the middle of that fraction. Since the negative is in the middle of the fraction, we don't know if the negative goes with the numerator or if the negative goes to the denominator. Correct? Do we all understand that? So you have to figure this out. Well, how do you figure this out? Well, you are going to say this. What did I just put up there? What did I just write up there?
The
quadrant signs that represent the cosine value and the sine value, and then underneath of that is sine divided by cosine, which is your tangent value. Do we all understand that? So what I just put up there is all the values for sine, cosine, and tangent, whether they are positive or negative in that specific quadrant. Now, if I'm looking at this right here and I say, hey, when my tangent is negative, what quadrants do I lie in? I can either be in quadrant 2 or I can be in quadrant 4. Yes? And that's with that little bit of information. Let's go to the next one. Out of my 2 yellow highlighted quadrants, when is my cosine greater than 0? In quadrant 2 or in quadrant 4?
Quadrant 4.
Which one? Is it greater than 0? In quadrant 2, my cosine, which is the x-coordinate, is negative, so it can't be that one. So that is a big no. It can't be that one. So I have to be in quadrant 4, which means since my tangent is negative and I'm in quadrant 4 has an x value that's positive and a y value that's negative. So that implies that the tangent of theta having a 5 over 4 being negative, the negative is going to go with the y value, which is actually in this situation going to be in the numerator. Do we all understand that? Tangent is understood to be y over x, correct? You needed to know where you're going to put that negative. Were you going to put it with the y value in the top, because it's tangent, or in the denominator with the x value? So now that I know what x and y are, x is negative 5. Oh, sorry. Y is negative 5, x is positive 4. I have to find r. How do I find r? X squared plus y squared is equal to r squared. So x is going to be 4 squared, negative 5 squared. So 16 plus 25 is equal to r squared. So this is going to give you a 41 is equal to r squared. So this is plus 41. No. This is the square root of 41 is r, or negative square root of 41 is equal to r. What did I teach you yesterday? R can never be negative because it is the radius measurement. Therefore, it's distance, and distance must always be positive, so you can't have that. So we know r is the square root of 41. Do we all understand that? Yes or no? So now that I know that, I need to find my 2 values that they're asking for. They're asking for the sine of theta, which is y over r. What is your y value? Yep. And your r value is the square root of 41. So that's negative 5 square root of 41 over 41. There is your sine. Now, what else is it asking for? It's asking for secant. So how do I find secant? Secant of theta is the reciprocal of cosine. Cosine is x over r. So what is secant? R over x. So that's the square root of 41 over my x, which is going to be positive 4. And you're done. Do we understand that? Do you understand why we had to figure out the quadrant in which we were in first based upon the information they gave us? We all good on that? Okay, why did I have to do that? Tangent was negative, but it was in the middle. So I didn't know if it went to the top or the bottom. The top indicates that it's a y value. The bottom indicates that the negative is going to go with the x value. So I know that it's negative, but it's either going to be negative in quadrant 2 or quadrant 4. Because sine divided by cosine, positive divided by positive is positive, positive divided by negative is a negative. Negative divided by negative is a positive. Negative divided by positive is negative. Those are your. So we're looking at one of these 2 diagonals, second or fourth quadrant. Then based upon this other bit of information, the cosine of theta had to be greater than 0. Greater than 0 means it's positive, right? So is cosine positive in quad 2? No, it's negative. So that means it's positive in quad 4, so that has to be quadrant 4. Which means cosine is positive, meaning x is positive, and y is negative in quadrant 4, which is why the y value had the -5. Does that make sense now? Okay, now with that being said, let's do actually problem number 67 in tonight's homework. Problem 67, they tell you that the sine of theta is equal to -3/5. And it also tells you that you're in quadrant 4. All right, well, let's take that little tidbit of information. If I'm in quadrant 4, my x is positive, my y is negative, my tangent's negative. Do we understand that, yes or no? If I am in quadrant 4, my x, which is my cosine, is positive, my y, which is sine, is negative, making my tangent and cotangent values negative. Now, here's what your brain needs to understand. They are telling you that the sine of theta is equal to -3/5. What is sine understood to be, definition-wise? It is your y over your r. Now, what did we learn about our r value? It has to be positive, which implies the negative goes with the 3 and the 5 remains positive. Do we all understand that? So I need to find x, y, and r. R is 5, y is -3, and I need to find x. So how do I go about that? X squared plus y squared is equal to r squared. X I don't know. Y is going to be -3 squared is equal to a 5 squared. So this is x squared plus 9 is equal to 25. X squared is equal to 25, take away 9 is 16. The square root, so x is equal to 4, and x is equal to -4. I'm writing them both down. Why am I writing them both down? Because it can be either one of them. Now I'm going to come back up here and I'm going to say, okay, well, what is x? Is x positive or negative in quadrant 4? It's positive, which means I cannot be -4. That means x is left to be a positive 4. Do we understand that? Because in quadrant 4, x is positive. All right, well now I have a lot of information. I can do any 4 of those trig functions remaining, or any 5 of those trig functions. It wants me to do cosine of theta. So the cosine of theta is your x over your r. So what is x? And what is your r? So you are done and you have 4/5. Do we understand how I expect you to do 67 through 74? We good? Yes? Okay, the next section is going to be 75 through 89. Listen to the instructions. Are you ready? Use a calculator to evaluate the trigonometric function. Round your answer to 4 decimal places. Be sure the calculator is set in the correct angle. For problem 75 through 82, you are in degree mode. For problems 83 through 90, you are in radian mode. So be very careful and make sure that you are getting the appropriate mode to do your calculator. Yes? I'm not going to go through those with you because you guys know how to do that, and I know that you know how to what buttons to push. Now, the next set of instructions is going to be 91 through 96. 91 through 96 says this. Find 2 solutions of the equation. Give your answers in degrees. 0 is less than or equal to theta, which is less than 360. And 0 is less than theta, which is less than 2 pi. Do not use a calculator. What they want you to use is your brain and unit circle. Specifically, quadrant 1 of your unit circle. You with me? So if I'm looking at 91 and it says letter A, the sine of theta is equal to 1/2. Well, okay. The very first thing your brain needs to understand is this right here. Tired of that yet? Where is the sign positive? Sine is dealing with which value? Sine deals with your y value. And where is your y value positive? Your y value is positive in quadrants 1 and in 2. Do we see that, yes or no? So if you're talking about quadrant 1 and quadrant 2, Using the hands of the clock like I taught you, your sine value is going to be your y value, and where in quadrant 1 is your y value 1/2? Y value is 1/2. Your y value is 1/2 over here at 30 degrees. So 30 degrees is equal to pi over 6. So I've gotten my answer in quadrant 1, but I still have to get my answer in quadrant 2. Yes? So in quadrant 2, that's going to be 180 degrees minus 30, which is 150. And 150 is equivalent to 6 pi over 6 minus pi over 6, which gives you 5 pi over 6. So those are the two angles that you should be utilizing. Right? Part B. Part B says, well, okay, I don't want it to be positive 1/2. I want to know when I have a negative 1/2. Well, what quadrant am I in when sine is negative? Sine is negative in quadrant 4 and in quadrant 3. Yes? So again, I'm still using that reference angle of quadrant 1 and saying, okay, the sine values still have to be 1/2, right? But I need to be negative. So if I'm in quadrant 3, I'm taking 180 plus 30, which is going to be 150. Sorry. 180 plus 30, which is going to be 210. Yes? Or 6 pi over 6 plus pi over 6, which is going to give you 7 pi over 6. Those are equal. Yes, that's quadrant 3. Or I have quadrant 4, which is the same scenario, but this time it's 360 minus 30, which is going to be 330 degrees, which is the same thing as 12 pi over 6 minus pi over 6, which is 11 pi over 6. Yes? And that is using the reference angle. So tonight's homework, 38 through 96 even. The rest of the time in class is yours to finish up your homework.